Right, hi guys. Today we are going to look at how we use all of our skills and knowledge of solving equations to look at equations a little bit differently. And instead of solve them, we're looking at how to rearrange them to help us with different purposes that we're going to end up looking at in the future. So here's our intro. Sometimes we have equations given to us with more than one variable. Now, in the past, we've been looking at just one variable or maybe variables on both sides of an equation, but it's always just been an x or a c or a t. Well, now we're going to look at equations that have more than one variable. And sometimes the way they give it to us isn't the way we want to see it. Sometimes we want to move things around to get a certain variable by itself. So all we need to remember is that we know the rules about doing the same thing to both sides of an equation, and we can use that even when we have more than one variable. So we're going to do that to rearrange some equations today. And the first example is actually a distance formula. We're looking at if you wanted to find how far you traveled. The formula to do that, the equation is your distance is going to equal your rate, your speed, times how long you go that speed, times your time. So that's an equation where you could use it to find the d, distance. D equals RT. But what if you don't want to find the distance? What if you know how far you want to go, and you know your maximum speed or the speed that you can take the whole time, but what if you want to know how long it's going to take you? Well, if we wanted to do that, we could rearrange this formula to get the t by itself. So it says t equals, time equals something, and then we would be able to plug in what we knew to find the time. So what we're going to do is look at this formula and say d equals r times t. Well, how do we get the t by itself? What's in the way of having that t by itself? This r, right? What is the r and the t? What's really in between those guys? Yeah, this is multiplication. When there's nothing in between two variables, two letters, it's always multiplying. So how would I get rid of times r to get the t by itself? Just like if it was a number, if it was times 2, we'd divide by 2. Well, times r, we divide by r. Whatever we do to one side, we have to do to the other. Now on the right makes it go away. R divided by r is just 1. Okay, that goes away. Over here, though, in the past, when we were dividing by numbers, we were always able to just do something divided by something and actually get an answer. Can we do d divided by r? Do we know right now what d or r are? Nope. So all we do is we just keep it as d divided by r equals t. Is the t by itself now? Yep. So we have a whole new equation or a new formula where we could use it to find how long it's going to take us, to find the time by just plugging in the d and plugging in the r, and then we'd be able to divide. If you don't like the t by itself over here, could we rewrite this as t equals d divided by r right there? Yep, either one of those. Now, did we get any actual answer for this? No, we're just rearranging it to get a different variable by itself. Let's look at another example. This is something that you'll run into when you get into high school in chemistry. There's this thing called the ideal gas law. It describes the relationship between T, temperature, and pressure, P, and volume of a gas. And there's some interesting constants. You'll learn about these all these numbers in high school chemistry. But we use it a lot to get different things. So what if we wanted to get this N right here by itself? We don't have any numbers in here. These are all variables right now. How would we get that n by itself? Well, what's in the way of having it by itself? The times r and the times t. So if we wanted to get rid of this r times t, we want to divide. It's all multiplication. Let's get rid of multiplication by dividing. We actually want to get rid of the times r and the times t, so let's divide by r and divide by t. The whole purpose of that is going to be that this r divided by r goes away, and the t divided by t goes away. It'll leave the n by itself. But whatever we do on one side, we have to do on the other. So now we've got our n by itself, and over here, we don't know what any of these are. We can't do anything else, but we can bring them down, and now we have a whole new equation where we know what n equals all of this stuff over here. So we rearranged it to get the n by itself. And all we're doing is just using our rules of what we can do on both sides of an equation. Let's do one more like this. This one's the formula for the area of a triangle. You guys used to do areas of triangles in the past. A equals 1/2 times base times height. Right? What we want to do for this one is we want to say, let's find out what the h is by itself. If we wanted to solve for the h, so when we say solve this for something, it doesn't mean we're going to get an answer. It just means we're going to get h equals and a bunch of the numbers maybe in letters over on the other side. So what's in the way of having the h by itself? This 1/2 times the b times that h. How do you get rid of 1/2 times? This one's an actual number. Well, if it's 1/2 times, we could divide by 1/2. What's that the same as, guys? Dividing by 1/2, you would flip this second guy and multiply. Dividing by 1/2 is the same thing as multiplying by 2. So if I did 1/2 times 2, it's just going to be 1. It's going to go away. Whatever I do on one side, I do on the other. So I'm going to multiply that side by 2. And if I bring that down, now I have 2 times a over here, or a times 2, equals, and now I just have my b and my h, b times h. So what was my goal? I'm trying to solve for h to get the h by itself. So let's get rid of this b times, and let's divide both sides by b. That b divided by that b goes away, and you end up with 2a divided by b equals h. So that one did have a number in it. Can we get any kind of solution from there? Nope. We just rearranged it so that the h was by itself. So that's half of what we're looking at, is taking some of these kind of common formulas and anything we see and be able to rearrange it to get a certain variable by itself. We're going to look at the next page and see a little bit of a different scenario. Same idea. Let me get my pages going here. Next page says solving for y. So on that other page, it was just solving for whatever variable we wanted to get by itself. And in all of these, if you take a look at all the examples on this page, they all have 2 specific variables. What are those? All those examples. All of them have an x, and they all have a y. And that's because the next unit that we are going to do is where we actually start graphing equations on the coordinate plane. And on the coordinate plane, you have coordinates, you have ordered pairs, x's and y's. And so we're going to be having equations with both x's and y's in them. And sometimes they're given to us in a format that's not as easy for us to use as what we're going to need. We need to be able to look at any equation with an x and a y in it, and we need to be able to rearrange that equation to get the y by itself. So that's why this is all called solving for y. It means get the y by itself. When the y is by itself, this is called function form, or sometimes we call it y equals form because that's what it looks like. Y equals something. The y is by itself. So let's try putting this one into function form, which means just solve for y, or get y by itself. Is the y by itself right now? Does it say somewhere just y equals something, something, something? No. It's kind of hidden in all of this mess right here. So let's start trying to get the y by itself. What's in the way of having the y by itself here? Well, that 9x and the plus and the 3 times, all of those have to go. So do you remember when we were solving equations and we had 2-step equations, we always had to undo the adding and subtracting first? The same thing here. We're trying to get the y by itself. We're going to undo the adding, subtracting. So how are we going to get rid of plus 9x's? Take them away. If we want to get rid of 9x's, we're going to subtract 9x's from both sides of this equation. I'm going to zoom in a little bit more here. You can see that better. Now this is going to be a little bit strange. On the right-hand side, 9x minus 9x is 0. That just goes away. But on the left-hand side, 12 minus 9x, is that 3x? Can I just go ahead and make that 3x? No, we can't, because 12 and 9x are not like terms. Right? 12 has no variable and 9 has that x with it. We can't combine those. So the only thing we can do is actually just rewrite it out like this. 12 minus 9x. That's all we can do. Bring down our equals, and what's still remaining over here? A 3y. So are we closer to having the y by itself? Sure. What do we do to get rid of this 3 times right here? We're going to divide by 3. Now here's probably the trickiest part, the new part that we're going to look at, is when we divide by 3, we have to divide everything by 3. Everything is going to go. So this term gets divided by 3, and this gets divided by 3. Everything. So when we look to simplify this, what is 12 divided by 3? 4, no problem. Now we have a minus here. I might change that into plus a negative, just so I don't make mistakes with any negatives in the problem. So now I have negative 9x divided by 3. Can I divide even when they're not like terms? Sure, because terms are only for adding. So I just do negative 9 divided by 3, which is negative 3, and keep the x there. And then that equals 3 divided by 3 went away, and there's my y. If you want to, you could put parentheses around there just to separate it from the plus. But guys, is the y by itself? Yep, equals y. It's the same thing as putting the y equals in front. That y is totally by itself. We have rearranged this equation to put it into a function form where the y is by itself. And that's going to be super, super helpful and important for us to do in the next unit. So we're going to practice it right now with all of these just to be ready. Let's do this next guy in function form. So we want to solve this one for y, get the y by itself in this one. Let's see what it looks like. Here's my equal sign. What do I need to get rid of first? I want to undo my adding, subtracting. So this plus 3x needs to go. How do I get rid of plus 3x's? Minus 3x's on each side. Over here, bye-bye. When I bring this guy down, I have 2y equals, and now can I make that 5x's? Nope, I can't. They're not like terms, so it's just 8 minus 3x. I'm just going to write it out long ways. Now at this point, I'm not going to leave it as subtraction. I'm going to change it to adding the opposite, again, just so I don't make mistakes with negatives later in the problem. And now how do I get my y by itself? How do I get rid of 2 times? Divide by 2. But remember, that trick is that I have to divide everything by 2. It's all got to be divided by 2. So right here, I've got 8 divided by 2, which is 4. No big deal. I've got a plus. Now this one, negative 3 divided by 2, is that going to be a whole number? No. So I've got a couple of options. The first is I can actually just leave it as a fraction. I can say, negative 3 divided by 2 would be negative 3 halves. Because a negative divided by a positive just makes the whole thing negative. So negative 3 halves and then the x. And I could leave it like that. If I wanted to leave it an improper fraction in this case, I could. Or I could simplify that a little bit more, and I could say, well, that's the same thing as 4 plus, what is 3 halves? Isn't it 1 1/2? I could say plus negative 1 1/2 x. I could make that negative 1.5x if I wanted to, but that's the idea. You might not have a lovely whole number right here for some of the answers. A lot of the times we end up getting fractions. All right, let's just do a couple more. Number 6, let's put this guy into function form. So we're solving for y, getting the y by itself, always, for all of these. So in this case, what needs to go? What's in the way of having this y by itself? Well, this plus 2. There's no x's over here. That's good. The x's are already on the other side. But how do I get rid of plus 2? Subtract 2. Okay. And then 2 minus 2 goes bye-bye over there. 6y equals. Now here, what can I subtract the 2 from? Can I just do the 4 minus 2? So x plus, and then 4 minus 2 is 2. Right, at this point, I'm ready to totally get the y by itself by getting rid of the 6 times. So I divide by 6, but I divide everything by 6. So I bring down my y. Now, what is going on here? There's no number in front. How am I going to do this? Well, if there's nothing in front of the x, what's really in front of the x? Yeah, it's really like a 1. It's like a coefficient of 1. So my fraction becomes 1 divided by 6, which is just 1/6. And you keep the x. There's no reason to turn that into a decimal when you've got a fraction that's nice like 1/6. And then over here we've got 2 divided by 6, which is just 2/6. You can leave that. How would you simplify 2/6? What's a simpler way to write 2/6? Could we write 1/3? So there we go. We're done. Guys, like I said, we're not getting any answers here. We're just rearranging this so that the y's are by itself. Okay, and then last one here, and then I'm going to have you try some on your own. This one's example 7. This guy looks easier, at least it's got smaller numbers. We're going to put this into function form. We're going to solve this one for y. So how would we get our y by itself here? Let's see. Get rid of the x by subtracting x. I just want to throw a what if. Guys, what if that was a negative x? How would you have gotten rid of a negative x? We would have added, right? I think in all of these examples, I started out by having to subtract, but you could also have to add to both sides. That's very possible too. So if I'm getting rid of my x, I'm going to do x minus x. Right? X minus x goes away. And what does that leave me with? Be really careful here. I'm still left with a negative y. So I've got negative y equals, and then how do I do 7 minus x? What am I going to write for that? Can I combine them? No, I've just got to write 7 minus x, long ways. Am I done? Is the y by itself? So close, almost. It's just this negative that's trouble for us. That negative y is really like a negative 1. So how do I get rid of a negative 1? We're going to divide by negative 1. That's a negative 1 times, so I want to divide by negative 1. Now here's where over here I've got to divide by negative 1 and divide by negative 1 everywhere. And this is why I was getting in the habit up above of changing the subtraction just to adding the opposite. Because if not, there's a lot of negatives going on in there with subtraction. I want to make sure I don't miss any of my negatives. So negative 1 divided by 1, bye-bye. And then you've got 7 divided by negative 1. Positive divided by a negative is going to be a negative. All right, sorry guys. And then we had the negative 7 right there, and we're going to add, and here we've got a negative divided by a negative, which is going to give us a positive. So, positive what? Negative x divided by negative 1, it's just going to be an x. So we've got our y by itself. This is why you've got to be really careful, because if you had left that as a minus, it's not as clear that you'd end up with a negative divided by a negative. So my suggestion is to change all that subtraction into adding the opposite. And then we've got our y by itself. So I'm going to have you guys do some where you're trying to just get the y by itself, and a couple others where you're doing the same idea like we did over here, where you're just rearranging some other equations to get a different variable by itself. And that is our goal for rearranging equations. So I'm going to let you guys do your practice work, and just remember to always do the same thing on both sides of the equation.